So let us compare stability of carbocation, carbanion and free radicals and check out their hybridization. So what is hybridization of a carbocation? It is sp2. For a carbanion, hybridization is sp3. For a free radical, the hybridization is sp2. Carbocation and free radical are electron deficient species. Carbocation and free radical are electron deficient, whereas carbanion is an electron rich species. Alright. The stability order for a carbocation is same as for free radical. For a carbocation, 3 degree is most stable, then 2 degree, then 1 degree. 1 degree is least and 3 degree is most stable. Same applies for a free radical. 3 degree free radical is most stable, then 2 degree and then 1 degree. And for a carbanion, the stability order is reverse of it, where 1 degree carbanion is most stable and 3 degree carbanion is least stable. Next we come to another intermediate which is known as carbene. So carbene is a intermediate which is having 6 valence electrons. For example, if I take Dichlorocarbene, so total valence electrons over here, valence electron in this one is equals to, see, you have 2 bond pairs. So 2 electrons over here, 2 electrons over here and 2 electrons. So total of 6 electrons. 6 valence electrons are known as sextet of electrons. For 8 valence electron we use a term octet. For 6 valence electron we use a term sextet. So a carbene has sextet of electrons. So what do you think? It is an electron deficient species or an electron rich? See, we always compare from an octet. So if 8 valence electron, that means the required number is there. If number is less than 8, then we say it is electron deficient. So carbene is electron deficient species. So will it donate a pair of electron or will it accept? I think you will say it is having 6 valence, so it wants to gain. It wants to gain. It is an electron acceptor. It is an electron acceptor, so it acts like a Lewis acid. Or it is an electron acceptor, so it acts like a electrophile. Alright. So carbenes are electrophile. For which reaction? My next question is, for which reaction carbenes are electrophiles? You don't know that, right? So I'll tell you, there are 2 reactions in your syllabus for which carbene is electrophile. First reaction is Reimer-Tiemann reaction and the second reaction is carbyl-amine reaction. In these 2, dichlorocarbene is the electrophile, and there is a very popular question which is often asked in different exams. And how are these formed? They are formed from diazomethane. By heating, what happens? Diazomethane, N2 gas is liberated and CH2 is formed as methylene carbene. And from dichlorocarbene can be formed by the reaction of chloroform with KOH. Chloroform is CCl₃, and when it reacts with KOH, and the reaction happens something like this. I have chloroform and you have KOH or a base. So OH minus takes out this H plus, so this H plus goes away, then you have a negative on CCl₃. So you will get trichloromethane anion, and from this one of the chlorine breaks the bond and this goes like this minus, and at the back you will have 2 chlorines remaining on the carbon with 1 lone pair of electrons, and this is the carbene we were looking for. So that is how dichlorocarbene is formed. So this is it for carbenes. We will be discussing others further. Thank you.